Good morning. I hope everyone got their coffee and had a good time until now. So let's get into it. My name is Ali Alp. I'm a distinguished software architect at BrainLab. And certificates, blah, blah. You can get the slides, if you wish, with scanning that QR code. That you don't need to bother with if there was a cool slide, where can I get it? So I give everyone some time. If it's always tricky, QR codes are not working sometimes. I hope it's working. Cool. Yes. We are in Germany. Why not? I made up a surname, Clustermann. So let's meet Leo Clustermann. He is responsible for security of Kubernetes cluster, a Kubernetes cluster. He studies, he patches, he stays up to date. He even gets a CKA certificate like me, to show that he's a Kubernetes security specialist. Yet somehow, he still gets hacked. But why? I think it all comes down into two factors, luck and perspective. Unfortunately, I cannot give you more luck, but ironically, with a bit of luck, I'm going to try to slightly change your perspective today. From this guy to this guy. Personally, I started realizing and understanding the security and how to secure actually the Kubernetes by actually hacking it, by actually trying to break it for fun. And I highly recommend anyone who is into the security business to actually do it. We have a thing with my wife. We call it 4D thinking, the fourth dimension. So there is like there's a vacation you see in the advertisement, and it shows a happy couple jumping into the pool. And there is margarita or whatever drink or pizza. And then the fourth dimension of it is that it's very hot. And most probably there are mosquitoes in the evening. And maybe there is a foul smell around that area. So that's the dimension that is not being included in the advertisement, right? So in my opinion, the security and learning about security is that three-dimension thinking, and actually trying to break those products that you are working with is the fourth dimension, that you actually come to a point that say, okay, now we are talking. So, are you ready to see Kubernetes the way a hacker does? That's an exciting question for me. Let's secure the network, right? I don't know why I included this slide, but it's just, if you go to the Kubernetes website and search for the security checklist, you come with a checklist that it has a type even checkbox, but it's disabled. So you cannot, maybe they did it for printing, I don't know. So the network security checklist, we have a lot of items here. So if you are a good system admin or security specialist, you know that where to go when it comes to documentation. You go to the Kubernetes documentation and you go to through the checklist. You got the CKS certificate, so you have hands-on, you know a lot of stuff. And you say, okay, my CNI plugin supports network policy, checked. Ingress, checked. Default network policies within the namespace, checked. So you go all the checklists that you have or you find. You search the internet. How can I secure my cluster, right? And the point is that whatever you do, they are best practices. They are based on stuff that's already being documented, already people suffered for it, and now it turns out on the Kubernetes website, and you can see and you say that, okay, access from workload to the cloud metadata API is filtered. Okay, why? Because so many people stole the cloud metadata stuff and got access to your account, or blah, blah. So as a good defender of the Kubernetes cluster, you say that for securing my network, you know what I'm gonna do? I'm gonna deny all, right? So I'm gonna make it dead, okay? So the pod cannot talk to anyone. It has ingress and egress, both deny all in the namespace of my namespace, which is demo, which is quite a cool idea if you have an application that doesn't do anything. But at least you need to allow it some traffic, right? And for sure, you must, actually, to allow DNS. Because the whole service discovery of Kubernetes is working with DNS. If the pod cannot communicate with the core DNS of Kubernetes, how can it resolve to the IP address of the pod and blah, blah? And we say that, okay, you know what? I'm going to allow this guy to only be able to talk to one IP address, which is the core DNS IP address, which is the internal core DNS IP address. So if you have a Kubernetes cluster, it has a core DNS, the core DNS has a service which has an IP. I'm going to allow only the one IP and only UDP 53 to be opened to this. And you think that it's just a simple DNS traffic, right? Plus, I'm only allowing it to the internal IPs. All good. Did you know about 91% of malware uses DNS? 91% to go and explore the world of Kubernetes or wherever they are. And about 70% of organizations experience application downtime due to DNS attacks like DDoS attacks, or 25% of it even don't collect or analyze their DNS traffic. You know, this is really shocking. So from the hacker's view, hooray, we have DNS there. Well, let's see what things we can do. So we could do today core DNS spoof special. This is the menu, you know, that the hacker is choosing from. Or, I don't know, the upgraded version. I didn't name this guy. I named the other guy Leo Clusterman. I forgot to name this guy. And the core DNS spoof special. Why resolve to the real thing when we can return, you know, localhost? Typo squat tenders, you know, oops. Did I mean kubedns or DNSS? Phantom domain curry, which it will bury or burn down the core DNS CPU because of a lot of very slow resolving or bad DNS that we can feed it to it. And even we could say that, why 53 UDP? Maybe they are looking into it. Let's go over HTTPS. Or I could just poison the cache, and instead of the pod thinks it's going somewhere, it goes somewhere else. Or my favorite, which we are going to dig into this one more, is DNS tunneling. La DNS cut 2, which is, you know, if you are into food, you know that the la carte or whatever, French stuff, the food. Yes. But what is DNS tunneling. So it's basically creating a tunnel through DNS. Abusing blah blah, looks like legitimate DNS traffic. I mean, sort of. We will see the traffic. And we can encode command into subdomains and command for C2. C2 is for 2 C's, which command and control, which you send the command to the victim and receive data. So with command, you control. So it's C2 and yeah. What will be the attack flow? We will do the pod, will send DNS queries, in this case to demo.alialp.de. By the way, you can reach me at that website. And not demo, but alialp.de. And core DNS receives it. So the cool part of it is this, that we send the pod is resolving a DNS query and says that, okay, I can talk to the core DNS. It's my trusted DNS. And core DNS receives it and forwards it to upstream because it doesn't have a clue where this thing located. So you know how the DNS works? It just goes upper, delegates to someone who knows where is this guy. An external DNS reaches the attacker servers, which is, in this case, mine. And the attacker sends commands back via TXT type of DNS query, DNS. And the core DNS will play a part for us. It just acts as a proxy for us and forwards the unknown domain, no filtering, and blah, blah. And why it works? Because DNS is always allowed. You cannot disable it. Core DNS trusts upstream. Well, we will talk about these things, but at the naive cluster that we have, it's, or naive, no, but I would call it medium rare cluster. And firewall ignores DNS. Yeah, a lot of firewalls just let it pass through. And the traffic looks harmless. It's just DNS. Yeah, I mean, most of the people, when they start TCP dump or whatever, they don't even look into DNS. It's DNS, forget it. No one will do anything there. And this is how it will look like. So we have a Kubernetes cluster. We have a demo namespace, which we have a DNS cat. DNS cat is a fantastic tool. If you don't know about it, I strongly recommend to look into it to get the hacker eye. And it has 2 parts. One part, because we are tunneling, we are putting data in the protocol that is not designed for what it's supposed to do. So we are putting stuff into DNS. So the client part will put that stuff into DNS, and then we have a receiving end, and we will be able to do some cool stuff. So we give the request to core DNS. Core DNS says that, okay, thanks. Send it to my evil red box, and then the rest will happen. So let's give it a try. Everyone can see, good. The font is good. At the back, okay. So now what we're gonna do, because I don't like typing in the demo. So now what is happening is that I am on this machine is not connected to anyone, right? It even doesn't have a Wi-Fi. It's just a Linux machine. And now I'm creating a Kubernetes cluster from scratch with Kind. If you don't know Kind, also please check it out. It's a fantastic project to actually literally do the playing thing that I just mentioned. If you want to break it, if you want to do whatever you want with your Kubernetes cluster. So on the left-hand side, we created a Kubernetes cluster. We created a namespace. We waited for all the Kubernetes stuff to come up, including core DNS. And this is the pod that we're going to create, okay, on this cluster in the demo namespace, which it just has a special image, which is DNSCat2 client, and yeah, and has image pool policy never, because as I said, this guy doesn't have internet or connected to anywhere, so it has to get it from the cache. And it just runs one command, which is DNSCat, and try to reach demo.alp.de. Yes, and on the right-hand side, we have our DNSCat server, which is running and waiting to receive traffic on UDP 53. And there's some magic. I put some stuff. I changed some stuff that this setup can work together. But you can think of that on the left-hand side, we have the Kubernetes cluster. And on the right-hand side, we have the attacker box, which is somewhere in internet, waiting for the connection, waiting for the core DNS to send the traffic from this guy to that box. All good? So we will apply this thing. Okay. So we got a connection there. One session arrived. And you can see here on this little box, what is happening is that we see the traffic of this specific pod. So if you are not also familiar with Sniff, which is a plugin of kubectl, please check it out. It's very cool. So you can actually sniff, very nice name, whatever is happening on this pod. So any traffic is going out or coming to this pod, you will see it here. And you can already see that a lot of DNS is happening already. You see a weird sequence.demo.alialp, a weird sequence.demo.alialp.de, and these are, we will look into it. But the thing is that now let's see what we can do. Now I reached the problem of one-handedness. So here, what we see is that if we say Windows, this is like a Chrome, you can think of it. So it shows you, and let me, it shows you the windows that are open right now. So one window there is open, which is the one tunnel, which is the connection between this pod and that DNSCat server, which is the evil box. And then if we say session-i1, we will get much closer. And if we say question mark, these are the things are listed that we can do. And one, my favorite one is shell. Please. Cool. The second tab opened. So we say session-i. Did I write correctly? 2. We got a shell. Let's see. PS. Cool. So now we can see ls for fun. So you can see on the right side, things are going as DNS. And by the way, this cluster is being secured by network policy, as we discussed. So the traffic is, the administrator is thinking that everything is closed down. It's only internal DNS is open for resolving the IP addresses of this thing. But in reality, what is possible and what is happening here is that all the traffic is being encoded into commands, which this is, for example, all the time is going, is for keeping the session alive. And we can do a lot of stuff now. We got a shell. And now let's see what things we can do. We could snoop around. We could get all the secrets of all namespaces, and you ask how, we could try to get the service account token. You know, if you don't disable it, by default, every pod will inherit the service accounts of that namespace. And maybe with the help of the kubectl auth cani -- list, you can actually list everything you can do with that service account. You don't need to try an error and try an error. It's just helping the hacker to go smoother and faster. You could figure out the environment variables, mounted secrets, which this is the path, and most probably it's always will be. Or worse, if you didn't apply policies, pod policies, then you could, and if you made a mistake and mounted somewhere on the host which is traversable, or you are really generous and you mounted / of the host, then bye-bye. Because then what will happen is that the attacker will be able to actually connect to this Docker sock or whatever you have, this run C environment behind the scene, and it can see the whole containers happening on. Because you think you have namespaces and they're isolated, but in reality, behind the scene, there is only one namespace in the Docker world, which is k8.io. One namespace for all the containers that you run in all nodes. So when you access to one node, you can see all containers in all nodes. And the bad news is that you can go even further and create a more privileged container by the Docker command or containerd or CRIO tools or whatever you have. And you can obviously try to see if there are things to steal, and you can, as I said, when you can see all the nodes and all the names, all the containers in other namespaces, and you are root in your pod, then what you can do is you can just attach to another container in another namespace. So the namespacing of Kubernetes is just a logical thing in Kube API. So don't think that this is a real isolation and you're going to be saved. I have this namespace, so I can put whatever I want. So if you put something dangerous, something that it's, you say that I have a dev namespace. In dev namespace, I'm putting all my dangerous stuff. I don't care. And I have a prod namespace. So if someone get access to your dev namespace, they can move up and then land in your prod namespace. Simple like that. I can target cloud metadata. Maybe someone left the IMDS wide open. Hello, AWS keys. And yeah. So now let's talk about DNS hygienes. How can we mitigate this, right? So we can try to only forward DNS to internal trusted resolvers. When you say that, send it to 8.8, send it to Google or whoever is behind it, then you have no idea what happens next. Use block or rewrite plugins to reject or redirect suspicious queries. So as we saw, there are a lot of subdomain queries going to the core DNS, which they are all weird. You know, anyone looks at that UDP traffic will say that, how is it possible that this guy is looking for these many subdomains? You know, then you could easily, if you look into it, which most of the admins they don't even consider looking into DNS. Alert on long and odd subdomains, yes. Forward DNS to filter resolvers. Yeah, this is a very good idea. Even you can prevent a DDoS attack and some other stuff instead of sending it to some unknown DNS or say that, this one is the, in internet, I will search what is the most private and quickest DNS server. And internet will tell me which one, and I put it in my Kubernetes cluster. Don't do that. And you can set DNS policy. If you are very panicked, and you say that this pod is very important, you can say that forget the core DNS. Okay, I will put in the configuration of this pod, I will say that DNS policy, none. Then Kubernetes say, okay, then I don't care. When you say, resolve this, I won't send it to, you need to take care of it yourself. So you can specifically for one pod or for one configuration say where to go to resolve that. And avoid forwarding dot. You know, if you wrote a DNS configuration, you know that dot means that whatever comes before, or in the reality is after but before, if you know what I mean. Only allow specific zones, like cluster.local, internal.company, things that you know about. Log and alert, this is very important. On DNS, you normally say, this is too much log, you know, this is unnecessary. No, log and alert. Spend time, 91%, remember, of the spy verb or whatever, they use DNS for going around. And block tunneling record types, like TXT or MX. Look into, if you need such a record type to be floating around, do you have anything using TXT or MX in your cluster? If not, you can block them. And only allow UDP 53 to core DNS pod IP. Block all other DNS path. So yes, we did this, and despite of this, we could hack the system. But have in mind that that is not a bad practice. I put this slide to emphasize that. That is actually a good practice, but we need to fix the core DNS stuff afterwards. So it's a good practice to only limit the traffic that must go to flow. Yes, thank you. Any question? Yeah.
Did I get it correct that part of the... Did I get it right that part of the attack is, of course, that I somehow have to bring my DNS cat client into the cluster by tricking the images or something like that into somehow going into Helm charts that may be deployed or something like that. So without that, it can't work. I need to bring in DNS cat into the cluster first.
So DNS cat is just a tool, and you can make your own DNS packets. It's not rocket science. It's just a tool to straightforward this process. And yes, you need to bring DNS cat, which you can bring it before deployment by I don't know, supply chain stuff. So no one can even know about it. And it can have different name, some look like a library, and then you can make it even on that machine. Yes, with curl you can bring it, with a lot of things you can bring it, or as I said, and even there is a Linux capability for ability to make TCP or UDP packets. Okay, so if you take that capability from Linux, the syscall won't even work. So you are not even allowed to make such a packets. But that's when you are securing it. But getting a tool into a pod, yes, you need to. But what I'm trying to say that is not a rocket science. Yes, question at the back. Yes, of course. Which one do you want? So, in my experience, actually, the thing that when there's a fact that it's not a matter of will you, it's a matter of when you will get hacked. Okay, so you're gonna get hacked anyways, and it's my wish always that if the cluster that I'm securing is getting hacked, got hacked by a professional hacker who used a sophisticated method, and not very trivial that my boss comes to me and says that, how did you miss that? So in order to do that, you actually need to think like a hacker. But in my experience, most of the security breaches that happened were mainly misconfiguration and or configuration drifts in the CI pipelines that or the developer is thinking that, for example, this is okay if I just put this host path because I want to share something between two, for example, containers or whatever, so I can use something for just matter of sharing. Even it's one of the best practices in Kubernetes documentation that if you want to, for example, share some data between these two guys, it's good to use, for example, host path that it doesn't have any data and you just use it because there's no guarantee that that thing will live on. But, for example, leaving the host path is a very dangerous thing that will, will give you a lot of vectors toward that. Yes?
One question, is there, in your opinion, a reasonable risk of breaking out of the container and even overriding DNS policies existing on the pod from the attack surface that you described?
What was the question?
What are the chances of overriding
Chances.
policies?
So DNS policies are just network policies and DNS policies. So for network policies, when you define it, it will go to IP tables somehow or whatever you have. Depends on your CNI or it depends on blah, blah. But at the end of the story, you need to be aware how these policies are being applied in the cluster. So that is the view that you will get if you say that, okay, let's set deny all on my cluster and now let's hack it. Okay? Then the mindset will go toward, okay, where should I look? Where are these policies? How they are being applied, because I need to know how they are working in order to find the exploit, in order to find the hole. So the mindset will change. So the possibility of changing a network policy is same as changing a pod configuration, or in the CI pipeline, or if you leave something open by mistake, or a drift in configuration, or all these things. So it depends, because hackers are patient. It's not that I will try right now, it's blocked. No, they will leave a script to try forever maybe on your cluster. And maybe 5-6 months later, you leave something open for development suddenly. Most of the hacks are happening not immediately after you have a consultants, security consultants, they come, they harden your system, everything is polished, everything is nice. After a while, because security is a marathon, it's not a sprint. So it's not that you secure the system and it's done, or it has an expiry date. It's a constant effort. You need to look into it and keep looking. So after a while, maybe someone leaves something open. Maybe you develop something. Maybe you add a health check. Health check endpoints? That after a while you say that, okay, I want to check the health of this pod, right? And I say that, is this API is running? Then the next day you say that, okay, I want to see that if this folder exists. on the container. And after a while, you see that the trend will go the way that you say that I want to make this health check dynamic. So I will provide a command to it, and it will run for me, And you are burned because you are giving a hacking tool to the hacker. You understand what I mean? So it's a time that it goes forward, and after a while, the security will get weakened. Yeah, no problem. Yes?
Yeah, I understand your point that when you are controlling all your cluster or your components, but when you are using the management clusters like EKS or EKS, whatever, main components like core DNS are not managed totally by you.
Yes.
How do you deal with this game?
You are not. You are leaving your fate into their hands, and they are really on top of their game most of the times. So if you, for example, when you are doing the DNS, for example, core DNS, which is in the AWS, the reason that they are saying it's a managed service is because they are managing it. So you could have deploy different plugins, or as I said, set, for example, if you want to get more customized, you need to use your own DNS provider, which can be a pod. You don't have to use core DNS of the managed services, but if you don't trust them, if you have a service that is really secure, want to be secured, then you will have your own thing and then take the control. Sorry? Depends on the application. Yeah. Thank you.